Hello students, today we finish IB Physics data booklet equation discussion. Today's equations are only for HL students. Page 8, equations. Topic, subtopic 9.1, simple harmonic motion. Abbreviation is SHM. Angular velocity and period are linked by this equation. For simple harmonic motion, we have the following formula for acceleration and displacement. As you see, acceleration is proportional to displacement, but with sign minus. Displacement in simple harmonic motion can change either according to sine or cosine law, depending on the start displacement. Accordingly, velocity will be derivative for x sine, derivative will be omega x0 cosine. If amplitude of a displacement is x0, then amplitude of velocity will be omega x0. And for cosine, derivative will be minus omega x0 sine. Relation between velocity and displacement is given by this formula. Kinetic energy, link between kinetic energy and displacement is this formula. Total kinetic energy is constant, this formula. Period of pendulum, L length of pendulum, and G gravitational field strength. Mass spring, M mass, K spring constant. Formula for period. So as I mentioned, to find velocity we find derivative of displacement, to find acceleration we find derivative of velocity. Single slit diffraction. For single slit with width B, we'll have diffraction pattern, and the first minimum will be observed at angle theta. This angle is calculated by this formula, where lambda is wavelength. Interference. Diffraction grating equation. So diffraction grating give maximums at several angles for n integer from 1, 2, 3 and so on. N is called order of interference. D is distance between lines on grating. To find them we divide 1 mm by number of lines per millimeter. Constructive interference condition is for thin film is when constructive is this formula, destructive is this formula. M equals 0, 1, 2. Resolution. First, to talk about resolution, we'll talk about diffraction on a circular aperture. So first minimum will be observed at this angle. Here we see factor 122, which is different from slit diffraction without this factor. By definition, resolvance of device is lambda over delta lambda, where delta lambda is the smallest difference in the wavelength that can be resolved. Here we have these two equations. First is definition of resolvance, and second is resolvance for diffraction grating. So n is the total number of slits illuminated, m is order of diffraction. For different order of diffraction we get different resolvance. Here they use Rayleigh criterion for resolution. If you have two wavelengths, they are resolved if maximum of one is on minimum of first minimum of another. So this is difference in wavelengths that is resolved, just resolved. Doppler effect. Due to relative motion of observer and source, the frequency of received wave either increase when approaching or decrease when separating. So formulas have plus and minus, so you should use this criteria. So when they, source and observer, are approaching, we should choose plus or minus depending if it should increase for approaching and decrease for separation. So here we have two formulas, one formula for source, moving source, another for moving observer. Moving source frequency increases if we have minus, decreases if we have plus. For moving observer, frequency increases when we have plus and decreases when we have minus. For light, which is also weight but moves at speed of light, we have the following formulas, where V is relative speed of observer and source. Example will be found for Doppler effect. When train approach platform, the received when train approaches platform, received sound has higher pitch, but when a train is leaving the platform, the received sound has lower pitch. Example of light. Our universe is expanding, so stars are moving away from us, Earth. Hence frequency decreases and wavelength increases as lambda equals c over f. This phenomenon is called redshift. All observed line spectra are shifted to longer wavelengths. This finishes page 8. We go to page 9. Page 9, describing fields. Work done in moving charge in electrical field. Charge Q over potential difference delta VE is given by this formula. If we move mass M in gravitational field and potential difference is delta V, we have this formula. Fields at work. Here we have analogy between gravitational forces and fields and electrical forces and fields. Potential is for gravitational field. Potential is energy per kilogram, field strength force per kilogram. Potential energy of mass m and force between masses m1 and m2 is given by this formula. For electrical field, potential for charge created at distance r from point Q is given by this formula, where K is Coulomb constant. Field strength is minus derivative of potential difference over distance. Potential energy of charge Q is given by this formula, and force between charge Q1 and Q2 is given by this formula. If you have planet or star with mass m, to leave this planet you should have minimum escape velocity. It is the minimum velocity required for object to leave planet or star. If you want object to orbit this planet or star, then it should have this velocity at distance r. Another useful formula of parallel plates. For uniform we have uniform field between two oppositely charged plates, and potential difference between these plates equals field strength by distance between the plates. Electric field strength and surface charge density. Surface density on plates is charge by area. Field strength for two plates is given by this formula, for single plate by this formula. The rest formula are mentioned in the formula. Here only we have orbital period formula. Page 9, page 10. Electromagnetic induction. So magnetic flux is quantity defined by this formula, where B is field strength, A area, and cosine of angle between the direction of field and normal to the area. If magnetic flux is changing and we have several coils, then EMF induced in this coil will be given by this formula. EMF also will be induced in a rod moving in magnetic field. The value of EMF equals field strength by velocity by length of the rod. If we have coil moving in magnetic field, then we include here number of turns, so we will have total length. Power generated and transmission. So normally power is transmitted in the form of alternating current, and it alternates according to sine or cosine. So this current has maximum peak values, and these peak values I can show you here. Peak values, I0. But we are interested in abstract constant current that produce the same power dissipation. So if we have alternating current, the power will be changing like this. And root mean square current is such constant current that produce the same power or the same energy for the same period of time as our alternating current. So this current is called root mean square current. Here we have relations between root mean square current and alternating current peak values. The same for voltage. For resistance we can use either peak values or root mean square values. For maximum power we should use maximum peak values. For average power we use root mean square values, and when we multiply square we get 1/2. This is famous transformer equation. EMFs or voltages in primary equals ratio of number of turns, and equals opposite inverse ratio of currents. Capacitance. By definition, capacitance C equals charge by voltage. If you connect capacitance in parallel, you add capacitances. If you connect them in series, you use inverse formula. Capacitance of parallel plate capacitor is determined by dielectric, by permittivity of dielectric material, area and distance between plates. Energy is CV squared over 2. Time constant characterize how fast the capacitor is discharged in the circuit if it has capacitance C and resistance of the circuit is R. Charge will be changing according to this exponential decay or decrease, current, this and this. So everywhere we have initial values and time constant. The interaction of matter with radiation. Energy of photon equals Planck constant multiplied by frequency of the light. Maximum kinetic energy escaped from metal after illumination equals energy of photon minus work function of metal. Quantized energy of electron in Bohr model of hydrogen atom are given by this formula, where n is 1, 2, 3, 4. n1 is ground state and n2 is first excited state. Angular momentum is p times r or mvr, and it also is quantized. It can have only such values with n integer from 1, 2 and so on. Schrodinger model, probability to find electron equals value wave function multiplied by the volume where we're going to find the electron. Here we have two Heisenberg relations which tell us that uncertainty in position and momentum are linked, greater one, smaller another. The same for uncertainty in energy and uncertainty in time. Here I have picture for quantized Bohr's energies of electron in hydrogen atom. So energies are negative. The lowest energy is ground state when n equals 1, and then they are closer, and finally the limit is energy of free electron. Here we explain the photoelectric effect. When photon falls on metal, electron can escape and the maximum energy will have electrons at the surface. Part of energy, F, work function, will be spent on escaping and the rest will be kinetic energy. This is why we have this formula. We can accelerate or we can stop these electrons. So this is stopping potential experiment. So if current is 0, it means that stopping energy equals maximum kinetic energy. Nuclear physics. Formula for radius of an element with atomic mass number A. R0 is Fermi constant. Number of radioactive nuclei left after time t. Lambda is decay constant or probability of decay. And activity equals lambda times the same expression as number, so it will also decrease. Electron behaves like a wave when the size of object is like nucleus. So nuclear diameter, lambda of nuclear diameter, will give us the first minimum of diffraction of electron moving through some lattice. Useful formula is relation between half-life and decay constant. Half-life by definition is time during which half of nuclear decay or activity decreases 2 times. After n half-lives, number of active elements will be given by this formula and activity by this formula. Finished. Congratulations. Thank you for your attention. See you next time.